agreement only because this is really basic algebra, and I just would like us to avoid coming back to it and explaining it again and again. So I just want to put it out of my mind, and knowing that you understand this, and you will see it almost every class. So these are three special products that are extremely important. So can anyone give us the answer to this other than Kyle? I always torture him when he. Okay.
A squared plus 2ab plus b.
Good. So this is, thank you, Michelle. So this is extremely important for several reasons. So first of all, to refresh your memory, this is a sum or a difference of two terms. The name of a sum or difference of two terms is a it's a binomial. So when we add or subtract two terms, what happens? What is the name when we know the terminology is very important, so for us to be able to communicate. And what are these called? These are called factors because they are multiplied. And I also told my previous class, so take a little notepad or index cards or whatever, and every day accumulate something in there. Put something in there, something like, well, binomial is the sum or difference of two terms. And when we multiply two quantities, they are called factors, and so on and so forth. And when you review this for any test or final exam, everything will be condensed, all the terminology in one place. And I can remind you or refresh your memory and say, well, we did this and that, but it's always the best to go back and review it yourself. So write down every important information, everything that you learned in each and every class, so you can go back and say, okay, I will not forget this. Once you write it and you review it, you will always remember it, I think. Okay, so for those of you who did not remember this, let's just do it one more time. So this is a plus b and a plus b again, and we will use FOIL. So this is a squared and then ab. Stop me if you have any questions, okay? Plus b. I don't know where you are and how fast we can go. Well, I shouldn't even write BA because AB and BA are the same. Of course, these two are like terms, and they will be combined. So we end up with a squared plus 2ab plus b squared. And I'm hoping that moving forward, although if you do ask, I will always answer, but I'm hoping that in moving forward, you will never ask, where does that 2 come from? So the 2 is coming from adding two like terms. So now the key is not to just remember this formula, our special product, but remember it is in the following sense. First term plus second term, everything squared. First term plus second term, everything squared. And what does the pattern say? It says first term squared plus twice the first times the second plus the second term squared. Why should I remember it like this? It's because I'm not going to get a and b to deal with. I'm going to get, let's say, 2x squared minus plus. Let's put plus first. 3y cubed squared. There is no a and there is no b. So how do I proceed? Okay, I have to square the first term. That's what this says. Then I have to square the second term to get this. And then I have to multiply them and multiply by 2 in front. So what will be the first term squared? Say it again. Very good. Plus. Remember the 2. 2 times 2 times 3. Very good. 12. X squared. Very good. Plus the second term squared. Very good. Excellent. So this is the key. This is the pattern that we look at. Is everyone okay with this? Yes? Okay, perfect. So then what is the second one? So what do you conclude? That a binomial squared is, what is this? How do we call this? If we call this a binomial, how do we call this? Very good. So please remember that. Which means if I ask you to square 2x plus 3, you will not say 4x squared plus 9, correct? Because this is a binomial and we expect a trinomial and we are missing the middle term. Perfect. So can anyone give us the second and the third so we can start? What about the second one?
A squared minus 2ab
Perfect.
plus b squared.
Perfect. And the last one. The last one is a different story. Yes. Yes, this is the difference of squares. This is a binomial, but we multiply two binomials that are identical with the exception of the sign. So this is always the case. If they are identical, except the sign, the result is the difference of squares. Good. Any question? Okay, I think we are ready to start that skills assessment. Yeah, it did. Actually, more than one. Perfect. Now, I don't want to bore you with this. You can say skip this if you remember it and we don't have to go through it. Okay, so let's read the first question. I didn't mean to print with the answers, but just printed with the answers. I have no idea. This is the first time I really printed out something from WebAssign like that. Okay, find an equation for the line that passes through the point 2, negative 2, and is parallel to the line 2x minus 4y equals 1. We should, I think, remember this. Ready? So if you want me to skip this one, I will. So we want to find the equation of the line that passes through this point and is parallel to the equation of this line. Okay, so what do we do? Any suggestions? Do we want to do this problem? I don't know where we are, so that's why I let you decide. We do it or not. Okay, perfect. So the idea is this. We have a line whose equation is unknown, but we have two pieces of information. The first piece of information is that it passes to this point 2 comma negative 2. It's going through it, passing through it. And the second piece of information that it's parallel to the line whose equation is 2x minus 4y equals 1. So we do have two equations that I would like to refresh your memory on. Y equals mx plus b, and y minus y1 equals the slope times x minus x1. The first one is the slope-intercept form. The first one, slope-intercept form. And what is the second one? Excellent, point-slope form. That's the second one, point-slope form. Excellent, good. So which of these two equations would you think of applying? Remember, the first one has the y-intercept. This is not a y-intercept. A y-intercept looks like 0 comma a number. This is the y-intercept. So we don't have the y-intercept. So we will be using the second equation. Okay, so now, in the second equation, I can put the point because the line passes through this point. So I will have y1, which is -2, and x1, which is 2. But I am missing a piece of the puzzle. And what am I missing is the what? Excellent. How do I determine the slope? Yes, we will solve this equation for, perfect. So 2x minus 4y equals 1. Negative 4y, we will be moving 2x to the other side. Negative 2x plus 1. And now we will divide both sides by. You're no longer banned.
Yeah,
Sorry.
You have a timid class this time around.
Okay, yeah, okay. Good, for now. They're just warming up.
Yeah.
Good. So we divide both sides by -4. So then -4 divided by -4 is 1. And -2 divided by -4 is 1/2. And 1 divided by -4 is -1/4. What is the slope of this line? 1/2. If the slope of, let's say, line 2 is 1/2, what would be the slope of line 1? And why is it 1/2? They're parallel. Very good. So now we have everything. So we have the point, we have the slope, and we can finish up the equation. So y plus 2 equals 1/2 x minus 2. Yes, we have to solve for y, but let me stop for a second and ask you if you have questions. Any questions? Don't be shy, please. Any questions? Okay, so I will distribute 1/2 and to both terms, and then I will subtract 2 to solve for y. Ready? So y equals 1/2 x minus 1 and minus 2. So then y equals -1/2 x minus 3. Let's see what they get. Oh, I wrote minus, but it's positive. I'm sorry. How did that happen? Y equals 1/2 x minus 3. Yeah, what did they get? The same thing. It's just written differently. Instead of x over 2, we have 1/2 x. Same thing. Any questions? Okay. Do we need to do problem 2? Is that a yes? Is that a no? Okay. So in problem number 2, we are asked to state the value of f of -1. So this is the origin. F of -1, I draw or imagine I draw a vertical line, x equals -1. It crosses the graph in this point, and I will be reading the y value. Can anyone read the y value? Right, so f of -1 equals -2. Okay, then they want us to estimate the value of f of 2. In the same way, f of 2, I draw a vertical line which represents x equals 2, or just imagine that I draw it. And this is the point, and I try to estimate that value. So they said here 2.8, but they should accept a wide range of answers. It can be 2.75. It can be 2.9. 2.85. I don't know how they do that. But so f of 2, what do you want to estimate it at? It's difficult, of course. Maybe there is a way in WebAssign to enlarge it and maybe be more accurate. What will you say? I'll write it. I'll accept it. Okay, we'll go with what they said. So for what values of x is f of x equals -1? In this situation, what do we need to do? We need to draw a f of x equals -1. What does that mean? Exactly. Y equals -1. So we draw a horizontal line, y equals -1, and it crosses the graph in 2 points. Oops. And we will look at 2 different x values. Can anyone give us those x values? X equals and x equals. -2 and this, yeah, this is the origin 0. Estimate the values of x such that f of x equals 0. What does this mean? Very important concept. Whenever f of x is 0, we are looking for f of x is 0, we are looking for x-intercepts or the zeros of f of x. Same thing. Or where the function crosses the x-axis, in other words. So we see that this function crosses the x-axis here and here. Hard to estimate, of course, from this graph especially. They said -2.5 and 0.3. I'll go with that, but if you come up with slightly different, I will accept them as well. So x equals -2.5 and x equals 0.3, x-intercepts or zeros of f of x. Okay, they're asking us to state a domain and range and use the interval notation. Do we remember what the domain means? Domain is values of x. See, the function starts here and ends here. On the x-axis, the function exists only between these 2 points, which clearly says that this is the domain. Notice that the points are full and closed, in other words. So we have from -2 to +3. I think 0 is here. Okay, 1, 2, 3. -3 to +3. Indeed. The range is measured on the y-axis. From the lowest y value, which is -2, till the largest y value, which is 3. And I will go with that. Again, we're using brackets. We're using brackets because the points exist. If they were open points, we would have used for the domain parentheses. And for the range, we would have used bracket here and parenthesis at 3. Are you with me, everyone? Any questions, please? Moving on. Yes? Yes? Anyone? Okay. Now find the domain of the function, and we have f of x, which is 2x minus 1, oh no, plus 1, and x squared plus x minus 30. What type of function is this, if you remember? It's a ratio of 2 polynomials.
Rational function.
Thank you very much. Rational function. If I identify this function correctly, I have great chances of finding its domain correctly. What could go wrong with a rational function? Exactly. So that's all I need. X squared plus x minus 30 cannot be 0. This is the method, this is the way of finding the domain. Okay, so then how do I proceed? What do I do with the left-hand side of this equation? Good, excellent. How do I factor the left-hand side? So then there are 2 possibilities that are not allowed for this function. Indeed, -6 and 5. So this is not the question, right? The question was not asking us to find which values make this function undefined. No, we're asked to find the domain of this function. But that's what I needed to do first, to find those values that x, for which x, that values of x that create, that make this function undefined, that I have to exclude from the domain. So since I'm excluding -6 and 5, I have to show in interval notation that I'm including everything else. I have to start with -infinity, stop at -6, continue from -6 to 5, stop at 5, continue from 5 to infinity, and this is the domain of this function. In plain English, everything but -6 and 5, exactly what you told me, but we are asked to present it in interval notation. Any questions? Any questions? Yes, please. This is the interval notation.
So, is there another way of doing it?
Yes, there is a notation called the set builder notation, but it's not recommended. The set builder notation in this situation would be kind of something like all x values such that x does not equal -6 and x does not equal 5. But this is basically what we just determined, just written differently. So we prefer the interval notation. Very good question. Thank you. Interval notation. Okay, next one is a different type of function. It's a combination. I don't have a name for it. So the next one, stop if you have questions anytime, please. I don't have a name for this function. First of all, it's a rational function, but it's not a ratio of two polynomials. The definition of a rational function is the ratio of two polynomials, done. But here it's a combo. It has a cube root at the top and a polynomial at the bottom. I don't have a name for it. It's a combo function. So again, we are asked to find the domain. Such a function of a combination of a radical and ratio can have two difficulties, right? Like before, one possibility is x squared plus 1 to create a problem in the denominator, but this is never the case. Why is it never the case for x squared plus 1? How come that x squared plus 1 will never be 0? That's my claim. Right, because it's a sum of two positive numbers. Even if this is 0, 0 plus 1 is still a positive number. So there are no restrictions coming from the denominator. Now, what about the numerator? The numerator is the cube root of x. Is there any problem with the cube root?
Can't be negative.
Cube root. Can I take the cube root of 8?
Yeah.
Can I take the cube root of 0? Can I take the cube root of -8? So is there ever a problem with an odd index? No problem. No problem whatsoever with any odd index. Even index, a different story. But odd index, no problem. So what is the domain of this function? There are no problems. No problems means that's it, all real numbers. Okay. Now, yes, please.
So what would it be a time when the numerator is like a problem with like
Excellent question. Okay, let's look at the problem. The square root of x plus 1 over the square over x plus 4. This function has two potential problems. Can anyone give us any potential problem here?
The square root can be negative.
The quantity under the square root. The square root is never negative. The quantity under the square root has to be positive. And what could be the other possibility? What the other problem? Yes. So now, when you solve the first inequality, you get greater than or equal to -1. When you solve the equation, you get x not equal -4. So both conditions have to be fulfilled. So the first one is -1 to infinity. And this one says not -4. So then the domain of this function, since this is not within -1 to infinity, will be -1 to infinity. If this number were somewhere here, like let's say +6 or +4, if I change this into negative x minus 4, then I would have had to exclude +4 from there. And the domain would have been -1 to 4 union 4 to infinity. But that's not the case because I have x plus 4. Is that better? Perfect. Okay, the next one is a totally different situation. Way more work. So let's take a look. Any questions for me, please? Any questions? Okay, so we have a function now, h of x, which is the square root of 7 minus x plus the square root of x squared minus 1. This is an addition of two functions, function 1 and function 2. If these two do not have a common domain, this function cannot be used for any purpose. So if these two are valid at x equals 3, fine. If they're valid at x equals 4 and 5 and 6 and 10, fine. Then the function can exist. But if these two pieces never have a common domain, never overlap, this function makes no sense because there is no number you can put in to create this result, to find a sum of these two. So as we just discussed, what will be the restriction for this and what will be the restriction for that? 7 minus x, not only positive, greater than or equal to 0. And what is the restriction for this? Has to be greater than or equal to 0. Indeed. Now I have to solve these two restrictions and see if there is a common territory. If there is no common territory, there is no function. So the first one is no problem, right? -x greater than or equal to -7. I moved 7 to the other side or subtracted 7. What now?
X less than or equal to 7.
Good. So the first one is completely solved. What about this one? And before you answer, let me write a note. We cannot take square roots from a inequality, from both sides of an inequality, unless in a very, very specific situation or circumstances, okay? Do not take the square root from, or apply from both sides of an inequality. So do not say I move 1 and take square roots. It's not allowed, not possible. So what do we do and what type of inequality is this? What type of inequality was the first one? Linear. What type of inequality is the second one? Quadratic, a totally different situation. Okay, perfect. So how do we solve a quadratic equation? Solving a quadratic equation. We have to factor. So please give me the factor form. Excellent. What I like to recommend, you use the method you like, of course, what I like to recommend is this table, in which I put in the first factor, the second factor, and then the product. Why is this row here? Because that's the variable in the problem. And it goes from negative infinity to positive infinity. That's the variable in the problem. This is the first factor, this is the second factor, and this is what I'm interested in. I'm interested in the product. Can anyone tell us where is x minus 1, 0? Where is the 0 of this factor? Very good. So we have to put in the table x equals 1. Where is the 0 of this factor? Good. Of course, we have to put them in ascending order. So I know it's silly. Which one do I put first? Good. And I write 0 under x for x plus 1 under negative 1. X plus 1 is 0 when x is negative 1. And I put in 1, and I put 0 under 1 for x minus 1. Okay. Now, remember, these are linear functions, correct? They both have a positive slope. Very important to remember this. So a linear function with a positive slope, does it look like this? Or like this? Good. So it comes from which sign?
Negative.
And it goes to which sign? That's all you need to know. They both have the positive slope. So the product under negative 1 and the product under 1, what do I write? Oh, one of them is 0. So what will the product equal to? Of course. Now I want you for the first subinterval to multiply them and give me the sign. I want you to multiply them on the second interval and give me the sign. And on the last one, that's it. Now, only now I look at what I want. What do I want? Which sign do I want? I want the positive. Is there anywhere positive sign?
Negative infinity and negative 1.
So here, this one will be negative infinity. So x, if you want less than or equal to negative 1, union, or in other words, 1 to infinity, x greater or equal to 1. Okay, we didn't finish. We have not found the overlap yet. We only solved two inequalities, a linear and a quadratic. We have not found the solution yet. But I want to stop for a moment and ask you if you have questions on this. Does it make sense? Is it clear? Okay, so now let's put on the real line both conditions and draw a conclusion. Okay, I will put in first 7, negative infinity to 7. Let's say I don't care for units. The blue territory is the first inequality. The second one is between negative infinity and negative 1 and 1 to infinity. And now I want both colors. I want the orange and blue at the same time. Why? Because the domain of this function exists only when both exist. Both exist where I see both colors, where I see blue and orange at the same time. And that would be the domain of this function. Ready?
Negative infinity to negative 1. Union. 1 to 7.
But this is not a trivial problem, right? It took us through a lot of stuff. Solving the linear inequality, solving the quadratic, factoring, using the table, or you can use another method with checking, find the boundaries and then check, whatever works for you. That's fine. And then I had to intersect two intervals. I had to intersect the orange interval with the blue interval. So this, just one of the problem, tests a lot of information, a lot of knowledge. Okay, moving on. Without using a calculator, make a rough sketch. Do you have any questions here for me? Any questions, please? Don't be shy. Any questions? Okay, so we have a function which is y equals x minus 2 to the third and plus 4. In the past courses, we talk about transformations. So what is the base function that was used to create this function, base? Well, let me give you a hint. Is it the square root? Is it the cube root? Is it natural log? Is it
X cubed.
You couldn't stand it anymore. Thank you, God. It is x cubed. X cubed was used to create this function. Good. Now, the first transformation on x cubed is, compare these two, and you will say, we are changing x into x minus 2. That's the first transformation in order of operations. But what does this mean? What am I doing with x cubed? Where do I take it to? When I change x into x minus 2. So this is x cubed. We haven't graphed it. We will graph it. So this is x cubed. So the origin, and it passes through 0, 0, right? So I want to graph now x minus 2. Do I go to your left, or do I go to your right 2? So remember where the origin was. So it's only a shift. So that origin still has to stay on the x-axis. Will it stay to the left of you, 2 units, or to the right of you, 2 units? To the right. Yes. So this is right 2. Because x minus 2, 2 minus 2 will be still 0. It has to stay. It did not shift up and down. It's a left and right shift. Good. I mean, in this case, right. And now the final transformation is x minus 2 cubed plus 4. Yes, this is indeed up 4. Because I'm not changing x. It's the same quantity, x minus 2 cubed, x minus 2 cubed. Now I'm changing y. This was sitting, the origin was at 0, 0, then it moved to 0, 2, and now it's up 4. Okay, so then let's graph x cubed. We have to remember the graph of x cubed. There are many graphs that I have to refresh your memory on. So this is roughly x cubed. And we have to shift it 2 units to the right to create the graph of x minus 2 cubed. So not perfect, sorry. And then, as you said, it has to be shifted up 4. So now this point goes up here. So this is x minus 3, I'm sorry, cubed plus 4. Any questions? So x cubed, please remember x cubed. Now the next one is the square root of x. Can anyone give us the domain of this function first? We talked about it a few minutes ago.